Hello. Is there anybody out there? That would be cool. Puppy bee. Samui. Hello. Konbanwa. Namaste. Hello. Konnichiwa. Wee beep boppy. Hello, namaste. Konbanwa. Ciao, bonjour, hello. Hello everyone, konnichiwa, namaste, bonjour, hola, how's everyone? Say hi if you're not shy, leave a like if you want to leave a like, that would be cool. Today we're in Japan, look at that. Milk. Name Name-san. Konnichiwa. Yeah. Say hi, everyone. Hold on. I'll be right back. I'm back. Don't go anywhere. Don't leave me, please. We're programming for the Nintendo Entertainment System today. It's a good one. Let's see if this does anything right now. I'm not sure. Not sure if this is going to really do anything here. Dragging the card in. Boom. Not doing anything right now, is it? Let's just double check that with the other emulator here. Wait. No, right now we're not doing anything. So, need to check some stuff here. So, what do we check? How's everyone doing? Say hello if you're thinking about saying hello now, because I just entered it into your mind, you know. This is not new code anymore. I don't know why it says that anymore. Bonjour, konnichiwa. Thanks for the likes, everybody. That helps out a lot. So we have this render thing. It tells the thing to render. Isn't that great? But we're not storing any sprite data right now. So that's a thing. That's a problem. We need to store sprite data. So I'll go to my other thing. This stores sprite data. Let's put that in here, I guess. Boom. And let's try this now. Is something gonna render? Hold on. There's nothing in the accumulator here. Let's load in number 1. How about that? I don't think I compiled, did I? No, I didn't. Still nothing. Weird. Probably not weird. It's almost certainly me making a mistake. 200. Loading in this number. Seems okay. Let's try putting this in the NMI here. Jump to subroutine render. Don't know if that will get it going here. Yeah, we got a number 1 displayed. Hooray! Look at that. It's amazing. It's the beginning of a whole new world of discovery, adventures. I'm putting things on this Nintendo screen. It's amazing. If you have any questions, please ask questions or say hello or somebody say something, anything. Konbanwa. Koko Nihon desu. Watashi wa Nihongo desu. That's a number 1 right there. Can we change it to a number 2? Well, we can go here and we can change this to a 2. Let's see what happens. We compile it. We drag in the new cartridge. Boom! Number 2. This is just incredible, guys. I don't know what to say. Like, my mind is blown here. But here's some character data. We had, there's this other one. I want to grab the face, man. The face. You might not be able to see it, but this is a beautiful face right here. It's in the ones and the zeros. You know, it's like I can see the matrix now. So that's number 24 here. It's actually 24 hexadecimals, so it's like, who cares? It's 36, I think. And we're gonna render the thing. So instead of 2 here, we'll put in a 24. Oh, we got a face. Got the face. We can be happy about that. That's a face. So I want to make it a body. I want it to walk around and stuff. There's actually a different mode here we can do, I think. Hold on. Make this a little smaller. I think we can handle that. Let's move things around a little bit, eh? Something like this. Is that better? And I think there's another sprite mode. I'd have to change all the sprites, huh? Wait, I'm not sure how that works. It doesn't have to be 8x8 sprites. You can do... It doesn't have to be 8x8 sprites. Here we go. For sprites, blah blah blah. Can be 8x8 and can be 8x16. That's exciting information, isn't it? So the palette is selected with a 2-bit value, blah blah blah, as we call it the attribute, blah blah blah. Yes, yes. SAP. See, I don't understand. I've seen this so many times. I still don't. I don't get it. What is? Okay, palette 4 to 7. Why does it say 4 to 7? Is that because those are the bytes? No. Can a palette be 4 to 7 of sprite? I just don't get what it's saying there. Okay, internal memory contains a display list of up to 64 sprites for each sprite's information. Occupies 4 bytes. That's the OM. Yes. You must subtract 1 from the sprite's y coordinate before writing it here? What? So any values between EF and FF will hide the sprite. Okay, cool beans, man. Maybe this is what I want. Tile index number 8 by 8 sprites. Yeah, I think that's what I want. So this is a tile number of this sprite within the pattern table. Oh god, this is exhausting to read, isn't it? In bit 3 of PPU control. So let's see the PPU control here. We do see sprite pattern table, blah blah. But I want the 8x16 mode. Okay, so on the, if I set this bit here is this H, I guess, is the sprite size. So if I set it to 1, we're in this mode. Huh. Interesting. Alright, to test it out first, I'm going to change our sprite to the first set of data that I've got, which is, I believe it's a 0. That's going to be here. So instead of the face, we're going to set a 0 here. Okay, so I'm going to compile that. And so it was a face. That was my sprite number 24, whatever. And I'm going to bring this over. All I'm doing is dragging in the cart. I'm creating this cart through compilation. I just drag it in there. So we got a 0. That's my 0 that it looks off. It just looks, doesn't look like a 0, does it? It just looks like a square. Anyway, that's my 0. And so I want to change the sprite, whatever it's called, sprite pattern thing, to 8x16 pixels. So we're going to do that by writing to the PPU control register, which is a 2000, memory address 2000. We might, so we have, we're writing to address 2000 right there. Enables the NMI, sprites from pattern table 0. Okay. So which byte is it? It's the third to last, I guess. No. Wait, what? Do my eyes deceive me? It is the third to last. Beep, beep, beep. Anyway, we'll set that to 1. Let's see how that goes. Let's see if that's going to do it. So this is sort of, you can think of that as initialization of stuff. Very good description by me. It's initialization of stuff. And let's drag in the new cart. Okay, so it's one sprite, but it's, you know, it's the 0 and it's the 1. It's just reading these bytes. I don't know what this is. This is sort of like padding. I don't know what this is about. Bunch of zeros. 8 zeros. Why? I don't know. I just don't know. Anyway, so this is a 0. If you look at these 1s and 0s, like these are the 1s. You can literally see it's a 0. 1, 2, 3, 4, and so on. So this is how I'm storing character data. But again, I don't really know what these... Wait, I think... Yeah, I think... Wait. This rings a bell now. There's some... I don't know, but I don't fully remember. We've got A, B, C, D, blah, blah, blah. All these letters all the way down to... Then I made this little face pattern. We got Z, Y, X. Coolness, huh? Isn't that cool? So, all right, well, we did that. What I'd like to do is make it a character, so not just a face. So, but I suspect the number is not going to be 24 anymore. It's probably going to be half that. Anyway, let's just fill in... Let's just change this up a bit. So I'm literally doing this to draw. So I'll highlight the ones for people so you can see there's a face. Let's make it into a body instead of a face, okay? This was a good idea to highlight this because it's much easier to see. So this is the body. This looks pretty weird. Konbanwa, Korera-san. Hello. Genki desu ka? It's sort of a blob right now, but let's try to make... I'm just going to gradually improve the drawing. For now, let's make it look kind of like it has feet. Like the most basic feet you could possibly have. So, there it is. Something like that. And... Oh, I changed this to a 1. I don't think I'm supposed to do that. Famicom no programming. So, I suspect... Well, let's try 12 here and see what happens. IJ. I to J wa F G H I. Oh. Interesting. Okay. So we'll try 24. Oh, there's our little character. There's our little character. So now I want the character to move. I'd also like to change the background at some point. These are things we want to do. Now we have movement. At some point was this tutorial thing has movement. I think did I do this in one of my programs? Not with the controller. So I want it with the controller. So let's see if we can figure this out. Alright, this is controller stuff right here. So I'm going to pop these in. Oh, this RTI is for the NMI. Read be done. Okay. Oh, sorry. Go here. RTI down here. This is the end of the NMI. NMI is like, happens once per frame, basically. So the game execution just flows down from the top and then enters this infinite loop, and then when the NMI interrupt happens, it execution continues here. And we have this render subroutine. Okay. To be honest, let's try commenting everything out here, because I think that rendering it, this will render it once, and I think that's enough actually, but let's test that. Now, I plan to make the character be able to move, so we're gonna have to switch it back to, so it's not rendering, okay. So we do need this. I've got the RTI, okay. Okay. That's fine. And so this is what has to do with the controllers. So this is basically saying to the controllers to, hey, get the input, basically. But let's look at what's actually happening here. So it loads in some information. I believe this is the controller data. This AND is going to make it look at the first bit here, least significant bit. So, okay. This is just for the A button. Okay. So this is moving a sprite around. Basically, this A equals A plus 1. I mean, they could have just done an increment, right? But anyway. Not sure if you... maybe you can't do increment on the A register, I guess. So... yeah, this is for the first sprite. And that is also the one that we're doing up here. So this actually might already result in the character moving around. Yep, I'm moving the character already. That's cool. However, it does this with the A and the B button, which is weird for me. So, both of these look at the same bit, the least significant bit. Does it just go in order? I don't know what buttons it's going to be next, so I'm just going to put C as a placeholder. And instead of the X position, we'll do the Y position, which is just going to be 0. I don't know if this is going to work. okay, so the select button is next. It's pushing it up, okay. So that's select button. Interesting. I'll just call it S. Well, S could be start. Read cell. Okay. You know what? I'll just make it verbose because people watching, it'll be easier for them. Coolness. I don't actually need this to do anything though, so. Again, we'll do the next button. I could have copied this before I started messing with it. Anyway, we got it the way I want it, and I think that's good. Let's test it. Okay, now the start button is moving them up. Okay. All right. So the next four, I think, will just be left, right, up, down, or something. So let me think. Okay. Yeah, let's copy this. Then just change this to read start. Okay. And text. Figure out what the next button is. So we have all of them. There'll be only 4 more. So now it's up. And this is still doing stuff which I don't want. Okay. So that's up. Okay. Up, I actually do want it to move up, but we'll change it back later. Actually, I'm not sure I want that. We'll see. So it's down. That's left. Last one will be right. But let's just confirm. Left. Comment this. Akiko, hello. I'm a cute girl. Yay. 今日はそういうので。またね。Okay, ありがとう。またね。So let's press right. Yeah, right. Moves it up. Okay. So this is right. Oyasumi nasai. Okay, I'll comment this out for now. Alright, that's a lot of code there, but that's good. Gonna have to have multiple files in the future, but for now, still just everything is in one file. So they have this for B and A, and I want... So A should move right. So we're going to copy this. Right. Move right. It's here. And this one is going to move left. So I'm going to push left. Oh. Right works. Oh, left works. Okay. I had to click on the emulator. So left and right work. Cool. Yeah, and it wraps. Interesting. It'd be cool to implement a jump. These are the only controls right now. Maybe I should do a background. I don't know. Background. So this program has a background. So we load the palettes. 2007 is obviously the PPU, but I forget what exactly it does. I shouldn't say obvious. It's only obvious if you know. Anyway, this is still loading palettes. Okay. Now we're loading sprites, and then we load backgrounds. This right now is loading 16 sprites. Huh? I'm not sure that this is... That makes sense, but that's what they've got. So we've got backgrounds and attributes. Then this is just basically just rendering. We've got the infinite loop. We've got the NMI, which actually is rendering. Well, these are rendering, like rendering settings, kind of. And then this is actually rendering. We've got the controller stuff going on here, which is interesting. Okay, controller stuff. Then what's up here? PPU cleanup section. Huh. That's something I haven't bothered with. Something that I have not bothered with yet. And then we've got some palettes. We've got sprite data, background data. So let's see what this actually looks like, this program. It's from a tutorial. And can I drag from here? I'm not sure. Hold on. No, I cannot. Okay. So that's fine. So this is what they've got here. I don't see the controls. Wait, hold on. Oh yeah, the controls move that part of the sprite. Okay, so I would like a background. I don't want it to look like this, but... So I think for palettes, I think we're good with the current program as we have it. Don't need to mess with the controls either. Wait, this is my current program. I thought I was looking at the other one. Where's the other one? Okay, sorry, it's here. Let's see. So palettes, they're loading palettes. I think what we have will work. Now loading sprites, we want to look at the background. So they're using this, this is a register in the PPU. Am I doing anything with that? Yeah. For the palettes, right. What about, I just realized you can't really see enough here. Okay. So you can see this is our current program, and this is the tutorial using as a reference here. So this data that is being sent here is is 2000. All right, let me actually consult with the tutorial here. It's the Nerdy Knights tutorial. Okay, here's palettes, palette data, load palettes, sprites, sprite data, blah, 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 multiple sprites, controller ports, some stuff about instructions, backgrounds. So we need a color palette, yeah, and then we need a name table. That's the actual, okay, the layout of the graphics for the background, and then attribute table. So we need those three things: palette, name table, and attribute table. So the palette, like the sprites, 16 colors in the background palette. So I don't think I need to do anything additional there. I think I already have the palettes being loaded. Now name tables, okay. 8x8 pixel tiles. Briefly, I'm going to go back to, just in case it might cause a problem, I'm going to go back to using 8x8 sprites, which is here. So I'm going to say, I'm going to just try to remember, it's the third to the right there. Let's just check what it looks like now. Let's use the other emulator here, hold on. Okay. Alright, so we just have that now, okay. But I'm just worried that might cause a problem while I'm trying to set up the background here. So 8x8 tiles. Okay, that's the resolution and everything. The top 8 and bottom 8 rows of pixels are cropped, I guess. Okay, that explains a lot, actually. So the final resolution is 256 by 224. One screen full of background tiles is a name table. I need more coffee. The NES has enough internal RAM connected to the PPU for 2 name tables. It sounds like one tile is represented by 1 byte. I feel like the sentence is sort of poorly worded, but I feel like that's what it's saying. The name table we will use starts at PPU. Oh, okay, 2000 is the PPU address there. I see. So I was a little confused because I knew 2000, the memory address location 2000. Wait. Isn't that where we initialize stuff? Hold on. Right here. Hello, Viper Gaming. How's it going? How you doing? So I'm confused because I thought the 2000 address was for initializing setup here, which is what we're doing here for the sort of initializing some stuff for the PPU, I thought. But here it's talking about storing name table data at address 2000. So I'm a little confused about that. Anyway, let's look at the attribute tables. Good. Glad to hear that. Good. I'm okay. Just trying to make progress with the programming NES games. Have you been playing any games lately? Okay, attribute tables may be the most difficult thing to understand. Each name table has an attribute table that sets which colors in the palette will be used in sections of the screen. The attribute table is stored in the same internal RAM as the name table. We'll use the one that starts at PPU address 23C0. Time here is almost 2 a.m. I haven't. Yeah, I had a meal. How about you? Screen is divided into blah blah blah. Okay, 32 by 32. That doesn't look 32 by 32. But this this is where it gets a little tricky, I guess. So I believe the CPU has to copy over this data from our ROM into the PPU. First name too. Oh god, this is exhausting. It's defined with each graphics. This, I believe, is the code from the tutorial. They have it in a little zip file, so you can zip, or you can download and unzip. So, okay, so this is nice though. They've got these commented, some brick tops. Sky. But here we've got the number 24 is just all over the place here. These are all 24, but they're just sky. Some brick tops. So we've got, for brick tops, got some other numbers like 53, 54, 45. That's it. Very confusing to figure out, but we'll get there. I'm going to be reading this at least twice, so I'm just doing a slightly casual reading first. Binary is used, yes. So editing the 2 bits. This is so small, right? Starting to remember some of the details. So for this tile data for the background, each pixel has 2 bits associated with it. Anyway, here's some attributes. They do, this is binary format. I don't get it though. I just want to see if this is, if these are the same instructions that are used for rendering sprites. Because this, we don't have any background, but we have a sprite here. Actually, it's different. So it's 2003 and 4014 for sprites. Okay. So this is for loading in background. And what we're doing is we're giving them 2000 address. First the significant byte, and then the less significant byte. So 2002 and 2006. It's right here. So I guess this is going to transfer a bunch of data from the 2000 address. So this is going to loop, it looks like 128 times. That's what this stuff is doing. So it's going to copy 128 bytes. And it stores it starting here. I think this increments by itself, 2007. Starts with this label. So is this 128 bytes? Maybe, I don't know. Let's count. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 bytes per row. So that's 32, 64, 128 bytes. Okay. Then we have some attributes. I'm not sure. Oh. So what does it say? It says brick bottoms. I don't know why this is here. Okay. But the attributes should specify the palette information for one. We were just looking at this code. Copies over 128 bytes. Now we load in some attributes. This we're also writing to 2007. It's going to be 8 bytes. So 4, 5, 6, 7, 8 attributes, 8 bytes. This is exhausting, but I think maybe really there's not that much more for me to learn, I think, about this stuff particularly. So I just got a few more grindy sessions. Like scrolling I haven't really gotten into. Obviously I need to learn how this background stuff works first. And then scrolling, and then a little more I gotta work on with the audio, but I've done most of the audio stuff already. Let me grab some milk. So yeah, just a few more grindy sessions and I'll be pretty knowledgeable. So I don't know why it's always 2007. But I guess if we're sending info to the BPU, I mean, 2007. Okay. What do they mean by the final changes? Pattern table 0, graphics for sprites. Pattern table 1 for background. Right, 2005, I remember that. Registers for scrolling. Cool. Two thousand, 2001 are sort of set up like what they're doing here. Enable NMI. Sprites from pattern table 0, background from table 1. So this stuff I need to kind of learn. I'll look at the docs, the reference for that. So let's look at 2000, 2001, the PPU registers. So that's here. And let me just see something. So this is 2000 write. We write to 2000. No, we write to 2007. But so I think the PPU just increments on its own as you write to 2007. That's why we keep writing to 2007 without any kind of offset. It's just going to the next byte each time for us. Okay, so this also. So it looks like we're storing palette information in 3F00. This stuff, this information, whatever it is going to memory address 2000. These should be PPU addresses. Attributes are going to 23C0. Then what I don't understand is that we sent data to address 2000, and then here we do this also for 2000. That's the part I don't get. It seems like we're using 2000 memory address 2000 for two different things. So I'm just going to Google NES memory 2000. Yeah, it's 1.79 megahertz on the CPU. 8-bit processor. CPU has access to 2 kilobytes of onboard work RAM. I'm just kind of curious right now. What is 800 in hexadecimal? That's that. So yeah, so this working RAM is 0 memory address 00 to 7FF. Then we've got the PPU, which is 5 megahertz. Wow. Way more than the CPU. That's interesting. Two kilobytes of video RAM. VRAM. $256 bytes for the sprites. That's the OEM data. $28. That's going to be, I guess, yeah, for the palettes. Talks about the resolution. Then the APU. Controllers, blah, blah, blah. Anyway. So I guess Pong 2 goes into some of the arithmetic for displaying numbers, like for displaying high score kind of thing. Good to know. I was trying to implement that myself. Let's go back to the background stuff here. So, Let's check. Actually, I think in the beginning they talk about the architecture. Maybe I'm missing some details. So let's maybe go through the whole thing. So number systems, binary, hexadecimal, instructions, variables, control flow. Let's look at the system architecture here. Okay. So, overview of the NES architecture. Yes, yes. We've got ROM, we've got RAM, we've got CPU, we've got PPU, we've got APU. Blah, blah, blah. Good, good, good. Kilobytes. That's what that is. Okay, just explains some terminology. No problem. System overview. I don't know what UHF is, but whatever. No new info there for me. Extra PPU RAM sometimes, okay. We don't need to think about a lockout chip. The lockout chip. CPU overview. Included memory space, 2 KB of CPU, RAM. La-di-dee, la-di-da, la-di-dee, la-di-da. Internal RAM is up to, actually it's up to 7FF, I think. So let's look. Okay, so we've got the internal RAM here. See, I don't know what this, what the 800 to 2000 is for. .32 KB cartridge ROM. Is that just the BRG? .32 kilobytes for PRG ROM. I think is that. Optional 8 kilobytes of WAM. I guess from 6,000 to 8,000. So 2 kilobytes is up to 800. So 1,000, the number 1,000 in hexadecimal is 4 kilobytes. So 2,000 is 8 kilobytes. So 6,000 to 8,000. Or really, 6,000 to 7 FFF is going to be your WAM. Okay, so 6,000 up to FFFF is accounted for, though we have some sort of flags at the very end here. I've seen a lot of stuff 4,000 related to APU. Controllers, let's see. We got controller stuff going on. Yeah, 4016. But a lot of that memory space is not being used or something, I don't know. PPU is around 2000. I guess it doesn't matter that there's, you know, quote unquote unused memory, because your PRG RAM is only going to be 32 kilobytes until you have mappers, and then you've got some WAM, WRAM, and you've got the internal CPU RAM. Okay. We don't need to account. So 800 to 2000 is nothing. Okay. Just have to accept. Yeah, Andrew, how's it going? Doing some programming. Hooray. Your program does not run on the PPU. Yeah. PPU is like a GPU, essentially. Okay. PAL has a longer V blank time. Yeah, I have a Discord. Hold on a second. 1 second. Grab a link. Da 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 da. I'm not signed in to YouTube. Not signed into YouTube. Hold on. Be 1 second. Yeah, I'm drinking coffee, but not too exotic. I used to roast my own beans. It's not too hard. Alright, finally. So let's see. Hidden use copy button. What? Okay. 1 second. Copy. Oh my god. Why does it... It's not copying. It's literally saying hidden use copy button. That's so dumb. What is going on? I'm using the copy button. It's not working. Crazy. I'll try making another link. Hold on. What the heck? It's not working. Yeah, seriously. So weird. So weird. Yeah, it doesn't want to copy it. Craziness. Well, what I can do is tell you, let's see. My username, huh? Here's my username. Yeah. Okay. What was I about to do? We're just reading through here, I think. So PAL has a longer v-linked time. I shouldn't have closed Discord. Let me know if you send me a message there. Gibson Shell, is that you? I wish I could invite you to the server. I don't know. What the heck is going on with that? Is there something wrong with the copy paste on my system? I'm just so confused. All right. Cool. All right. Yeah, so PAL has a longer v-blank time. Yeah, I'm drinking coffee, but not too exotic. I used to roast my own beans. It's not too hard. All right, finally. So let's see. Hidden use copy button. What? Okay, this is probably some important information here in this table. Copy. Let me use the restroom real quick. Oh my god, why is it? It's not copying. It's literally saying hidden use copy button. That's so dumb. What is going on? I'm using the copy button. It's not working. Crazy. I'll try making another link. Hold on. What the heck? It's not working. Yeah, seriously. so weird. So weird. Yeah, it doesn't want to copy it. Craziness. Well, what I can do is tell you, let's see. All right. Let me try to read this table. Whew, it's tiring and exhausting and crazy. Wow, what is this? We got up to almost to 4,000 in memory, so that's going to be, I believe that's going to be 8 kilobytes of memory here. Anyway. No. I don't know. It'll be 16 kilobytes, okay. Yeah. So we've got cartridge, hold on. Cartridge RAM/ROM. I think the way they're writing this is confusing. Let's read the explanation a bit here. Good to know about this program. I don't have that yet. So there should be 256 bytes somewhere for the for sprite information. So I said 256 bytes. Yeah. I like how it gives us this chart and doesn't really... I mean, I think it's the PPU memory, but... Let's see. 16 kilobytes. Do we talk... Is there something that was 16 kV? Learning to program is like forging metal. You hit it as hard as you can, and it seems like nothing happens, and exhausting. Well, I've been programming for more than 10 years. I just wanted to do it, that's all. Yeah, how about you? So I've been able to make pattern tables and display... I've been okay displaying sprites and making the move, but not so much for the background yet. I don't really know too well what's going on with background stuff. But at some point we have 2 bits per 2x2 tiles stuff going on. That's also... I do not really know what's going on there. Come from a family of cyber criminals, huh? Jeez. What kind of programming do you normally do? Hacking? Well, I'm thankful for this information. I don't feel like... It's just giving a very broad overview here. 16 by 16 pixel area can only have 4 different colors. 2 by 2 tiles. I was thinking 2 by 2 pixels or something. Tiles. Okay. Now that makes sense why they were drawing things a certain way earlier. So we go down here. I just want to see what this is in the PPU mask here. We never really want to do this. I don't think the graphics end up looking weird. I don't see why you do grayscale, but if you wanted that. These are the interesting ones, I guess. Definitely we're doing this almost always. Probably want to do this at some point. And then stuff to do with clipping. Just sprite data. Okay. Which set of 4 from the 16 colors? Learning to write AI. Trying to find a new language for that. Nice. If you're into that kind of stuff, probably, well, not for AI, but if you're interested in hacking and assembly and stuff, you should learn C as well, maybe. It's generally pretty useful. For AI, yeah, I don't know. I don't do much AI stuff. Mostly people use Python, I guess. Most of this is review for me, but anyway. Once the second write is done, all data for the 64 sprites will be copied. Should be done at the beginning of the VBlank period. So let's see. So PPU control address 2000. So they're enabling NMI. That was, I believe that's this bit. So no, it's the last bit. The last bit is enable NMI. We have sprites from pattern table 0. This bit is being toggled. Background pattern table address. So I believe it seems to me that this comment. Oh, okay. This is a 0, so that's pattern table 0, and this is a 1. That's for the background pattern table. Background and then sprite. That's the 2 middle bits. Background and then the sprite pattern table. This is exhausting. And then the base name table address will be 2000 because it's a 0. Base is 2000. Got these other options. Increment VRAM by 1 going across. So I'm going to add some comments. What happens if I copy paste this in here? I don't think it's gonna come out nice. Okay, I can do that. Cool. So base name table address set to 2000. VRAM increment 1 horizontal. That says the other ones, but I'll just write it anyway. Sprite pattern table 0. Background pattern table 1. Sprite size. 8 by 8. Activate NMI. That's an interrupt that happens each frame. Okay. I mean, this code right here is from the tutorial that we're looking at, which is Nerdy Nights. This is the best tutorial, but it's also kind of the most hardcore. I mean, it's kind of intense starting out. So, but there's only so many tutorials out there. So, I've used kind of all of them, all the stuff on YouTube, all the text stuff you find when you Google it. There's only a handful of each. But Nerdy Nights is probably the most helpful, most detailed, and most intense. So I recommend, if you do this, sort of warming up with the other tutorials and then coming to Nerdy Nights. My code is over here. Some of it, most of what I do here on the channel, I'm happy to share. So let's see where we're at here. Let's use this one. Actually, I mean, it's this face looking thing, and I can move it around. That's about it. I mean, I could also do... I could use any of the buttons from the controller. A, B, start, select, up, down, left, right. We're just using left and right. And I want to get a background in there. We've got palettes. We've got rendering the sprite. Yeah, that's what I got going on. And I've got other projects. I've got like a print binary one that I did yesterday, not on camera. I've got... I mean, that's about it, roughly speaking. That's about it. What's the difference between NES, ASM, ASM? NES ASM is going to be... It's basically 6502 assembly, which is quite famous because it's not just the NES, it's also the Apple II, the... I think it's the Commodore 64, the Atari 2700 or whatever it was, and for people in the UK, also the BBC Micro. So the 6502 assembly was for many different systems, very famous systems. You only have 3 well, you have, in terms of your basic registers, you have 3. There's an X register, Y register, and there's this A register called the accumulator. So, like, these commands are like store the accumulator, store the A register in these memory addresses. This is load into the accumulator the number 0. These are store the X register into these memory addresses. Load the hexadecimal number 40 into the X register, these kinds of commands. But yeah, you don't have an enormous number of registers. You also don't have any multiplication command built in, and forget about division. There's no division, modulo, or multiplication commands. Also on the Nintendo system, although this isn't true of 6502 in general, but on Nintendo, there's no decimal mode, so all the numbers are hexadecimal or binary. I mean, this could be done... I mean, this is something in hardware, I guess, but I mean, it could be implemented in the assembler, you know, but whatever. So yeah, just using hexadecimal or binary. So we've had 2000 and 2001 here, if I remember correctly. This is PPU control. This is PPU mask. And let's bring in this stuff over into our project here. This information. So that's here. So all this is doing is enabling the NMI, but it's also, yeah, sprites from pattern table 0 and other stuff like this. So let's also want to bring in here. The only difference is this one here. So background pattern table 0. Hold on. Background pattern table 0, which maybe I should change that, huh? Hey Young, how's it going? Oh, thanks. Yeah, so the assembly, it's 6502. I'll just type it in chat if I can. So you can copy, you can search online if you want. Alright, so I've done a really good job of sort of annotating this stuff, but what about for the PPU mask? It'd be nice to have similar comments and so forth. But we might not get that here. So let's go to the docs. These are sort of unofficial. There's no official reference for this stuff, but we've got this information. So this is what we just worked on, or what we just looked at. There's also this other bit, PPU master slave select. I don't know. Maybe we can ignore that. I have no idea what that's about. Okay, let's go to the PPU mask. That's 2001. Right, this stuff. Okay. We'll just type that in. Even though it's a lot of info here, but I'd rather be pedantic and verbose and have more information than less information. Okay, so we're not emphasizing any colors. Then we're enabling sprite rendering. We haven't enabled background rendering, so that could be important. So let's do that. I don't think it's going to change anything, but let's see. Ooh, we got a background. Oh, well. There's background. Look at that. It's background. Coolness. We have background. That's exciting. Even though it looks blah, but whatever. So, reset, clear memory, load palettes, set the PPU stuff information here. Write a sprite, render it, controller stuff. I'm actually surprised that the background is being rendered. Can't talk like now. I'm out of the house. Talk in the car. Okay. Yeah, I'm just trying to get a lot of stuff done here. It's not going to be the most interesting stream, maybe, but getting stuff done. But yeah, I'm not actually sure why the background is rendering. Also, I'm guessing it's rendering this. And let's test that. So let's add something here. Yeah, that was correct. And it's just repeating that, just tiling it. Maybe... Let me try something. So CF is going to be, wait, is it CF? No, 3C is cyan, one of the cyan colors. So I expect this to change the sprite color to cyan. But actually, let's make it 2C. It's a more normal cyan. Let's see if that does what I think it's going to do. No, it changed. So, okay, wait. So this palette's getting used by the background, and this palette's being used by the sprite. So I believe that would be here. Wait. Yeah, I don't fully understand everything that's going on. So we're writing palettes to this 3700 address. Oh, that's not what I wanted to look at. But wait, maybe they have a better explanation of PPU memory in here. So we have some registers. That's interesting. These registers, PP registers, are mirrored in every 8 bytes, up to 3FF. Wow. Okay. This is why we wait for one V blank before messing with these registers. Whew. Okay, Young. Thanks for saying hi, though. Have a good one. Let's check out the memory. Here are the palette. I feel like this information wasn't in the tutorial, but whatever. So the palette RAM indexes are at 3F00. 3F00 is where we're writing these palettes. There's 32 bytes being written here. So we've got a 16 kilobyte address space on the PPU. 0 to 3 FFF. These docs are quite a doozy to read. But I gotta grind it hard. So the only access of the PPU, it sounds like it's through CPU. Basically accessing these two addresses from the CPU. So we do see that. Now let's look at the tutorial code here. So, okay. This is basically the same as my code. 2007, we're writing palettes, 32 bytes of palettes. And then these sprites are being written into the CPU memory. Now for the background, again, we're using 2007. But here the address is 2000. For palettes, it was 3700. I think I understand the question I had earlier. So I was confused about... So this is 2000 on the PPU. But when we access memory address 2000, where are you? Like here. This is from the CPU's point of view, which is going to map to the PPU control register on the PPU. Hello, Neon. Welcome. How are you? So this 2000 is from the perspective of the CPU, but it's actually not memory. It's not CPU memory. It's still on the PPU, but it's somewhere else. Okay. It's a kind of how to explain it? It feels like a bit of smoke and mirrors, a little bit, in a good way. Welcome back, Andrew. Phone was dying. Neon, are you a programmer? Welcome to the stream, by the way. Yeah, so I answered this question I had before. So the 2000 here is on the PPU. And then the 2000 here is also on the PPU, but it's not actually the PPU memory address 2000. It's 2000 from the point of view of the CPU, which is going to modify the PPU registers, which actually are stored on the PPU mirrored throughout these spaces here. So it's a little complicated. Feel inspired. Good. Glad. Okay. What's your end plan mastering this stuff? Any project? Well, I want to be skilled with this stuff. I mean, I might want to get a job working in embedded programming. embedded systems. And I think that this is an excellent way to learn that kind of stuff. I'm pretty good with programming in C, and after I'm sort of master, or at least get really good at doing this in 6502 assembly. You can also write these NES games in C, but I don't think that's how people did it back in the day. But it's a thing. So it would be nice to, like, I've learned assembly before, but I just learned in the past. I've learned sort of how it works and everything. One thing that confused me learning assembly on the x86. So I say learned. I didn't actually write any real programs. I just looked. Oh, this is how assembly works. Okay, I learned how to compile it, and not that much more. But anyway, one of the things that confused me is you have a lot of registers with x86 stuff, and that sort of overwhelmed me. I didn't really know what to do with all of that. And actually, with 6502, you just have... you have a lot of registers, but the main... What do you call it? Like, the main working registers that you're using with the CPU are the X register, Y register, and the accumulator. So it almost feels like you're so severely limited compared to x86 that you better get your stuff together, right? You better learn what you're doing. I think it's cool. It's very different from all the programming I've done before. But I'm also interested in making games, and I've always wanted to get sort of to the fundamentals. Just like if you wanted to be a good chef, you need to cut thousands of onions and work on your knife skills, right? Just cutting vegetables and cutting meat. And for me, a lot of the game development stuff I've done Unity, and I've made my own engine in C++, in C, done a bunch of OpenGL stuff. But yeah, doing this, making a NES game in assembly is really getting to the foundations, in a sense. So maybe continuing with game development stuff, I don't know. So I've made it this far on this page here, so I'm kind of tempted to just read more. But I think it's going to be a slow, gradual thing there. I don't have that much energy to read that right now. So we saw with these name tables, okay, 2000, 2400, 2800, 2C00. These were options that we had available to us. Here. And so from 0 to 3FF, that is going to be, that's 4 pages. So I guess it's like a kilobyte, I think, yeah. Hi, Crossfuss. Yeah, I agree. The basics are the basics. Extremely limited. Absolutely. Yeah. And writing 6502 assembly just really changes how you think about programming, I'm finding. I've never had to do... It's just very different from anything I've ever done before. 2 kilobytes of RAM. I thought this would be 4 kilobytes. We did this before. 800. This is 2 kilobytes, right? Wait. Yeah, this is 2 kilobytes. So wouldn't... Where were we? Here? Wouldn't that be 4 kilobytes? Huh. Yeah, even compression techniques, true. Yeah. Yeah, that's another good point, is that sort of actually having being faced with really serious limitations can cause you to learn a lot. Learn about optimization, learn about compression. I've also, from a game development point of view, I've always wanted to make like retro looking games, like old school looking games. And just using like a small, like all the stuff that people would tell you to do was never satisfying to me. Just using a small frame buffer. You know, there's a lot of stuff going on here with the Nintendo entertainment system that gives it a retro feel that you can't easily just copy with something like, say, OpenGL, unless you would need to already know how all this NES stuff works, and then basically almost emulate the whole system if you wanted to really copy it, right? And it might seem like overkill, but I also want to be able to write... I also want to write an NES emulator as well. So it'd be cool to have a game I wrote myself running in an emulator I wrote myself. That would be cool. I also think that if a person's ever interested in writing a programming language, which I'm also interested in, but I've never attempted, but if somebody's interested in that, I think they should learn C, they should learn assembly, and then have experience, writing C code and writing assembly code, and then comparing and contrasting, seeing can you optimize further. And, if I were interested in making computer languages, I would study C compilers. GCC, the GNU C compiler, for example, C-Lang. Those might be big ones. There's a simple C compiler out there. Smaller C, 8cc. So if you're interested in making languages, you need to learn how to write a compiler or a interpreter, I think. If you don't know how to do that, I don't know what business you would have coming up with a language. Same thing with Game Boys. Yeah, I'm interested in the Game Boy one as well. Yeah, I'm interested in old school DOS, SNES, PlayStation, sort of building up. But I want to get this foundation really rock solid. Then I think like going from here to SNES, I don't think will be that big of a deal. There's definitely some added, stuff on top. But I feel like if I want to do SNES programming, personally, I would want to really get good at this first and then build up. So I'm kind of lost in all this, the tutorial and all these reference pages. I'd really like to understand the memory on the PPU better, though. We've got these palette RAM indices, so we have 32 bytes here. That's how we're doing things. This is just some mirrors. We don't care about that, I don't think. Got some unused stuff after 3000. So we're saying 16 kilobytes. You get it? Mm-hmm. Cross Plus, do you do some programming stuff? So 1000 would be 4 kilobytes. 1000 is 4 kilobytes. So this is 4000, should be 16 kilobytes. That makes sense. So we're going from 0 to 3FF. That's all of this. This is just the very end here. That's not a lot of... That's less than a page. Less than 256 bytes. And so, okay. We don't worry about that. As far as we're concerned, this is sort of the end of the memory. And it has a very specific function related to palettes. And we are using that in our program. Okay, cool. Then we've got this stuff. This is cool AF. Nice. I'm glad you're interested. What do you think is cool? Are you looking at this stuff on the side as well about the PPU and that kind of stuff, the architecture? Studied it on and off around 2020. Forgot a lot of it. So yeah, this is just unused. Okay, that's a fair amount of memory as well. But whatever. So other than we do this stuff for the palettes, and other than that, now we've just got to worry about from 0 to 2FFF, which is about 12 kilobytes of space. And this we've already talked about, the name table stuff. So one name table is 512 bytes, is that right? My math is off somewhere. It's a kilobyte, right? Wait, yeah, it's a kilobyte. My bad. So one name table looks to be a kilobyte. Okay, then we've got these two pattern tables, which are themselves, what is that, 4 kilobytes each? Is that right? That's why I like the handheld computers. Yeah? I played Game Boy when I was a kid, but I think by the time I got Super Nintendo, which I was probably like 8 years old or something, by then I wasn't playing Game Boy much, and I haven't really played handhelds much since. But it does seem cool. Like, the Game Boy has all these crazy accessories, like Angry Video Game Nerd did a video about that that's really great. And one of them is a keyboard. So, like, if I were on a plane and could figure out how to do like what I'm doing here, you know, writing code for the Game Boy, if I could just do that, you know, without a laptop, that would be interesting. I don't know if that's, it might be feasible. I don't know. Yeah, do you know that episode? It's pretty great. So these pattern tables, I'm surprised by the size here. Pattern tables. Let's go back to the tutorial and try to understand more if we can. I've gone through all of this, not necessarily all on stream, but each pattern table, it says 256 tiles. Yeah, so each Okay, so what I have in my let me show you printing binary. Let's see if this still works. 14. Who's making their own language? Not me, but someday. Maybe, you know. But if I ever made my own language, like I was saying earlier, I want to... I'm already quite good at C. Not, I wouldn't say mastered, but pretty good. And if I get extremely good at assembly and C, for me that's a prerequisite. At that point, I might be interested in making a language, but now writing an emulator doesn't seem that bad. There's a YouTuber Javid who writes emulator. Seems pretty reasonable. I believe there was a Game Boy cartridge about stuff outside of games. Okay. So anyway, so this is printing binary. So the number 7 is input here, and it's displaying that. So let's see, number 7 is here. And so we've got these chars. 0. So if I highlight all the ones, you can see this is forming in the ones and zeros. It forms a 0 and 1 and 2, and so the 0 and 1 in this program are from this char data right here. So I've got, and I did these myself, so some of them don't look too great, and all the letters. And then I think that's it. Yeah, in this one. So I forget why I was bringing that up. Okay, so we have this CHR data. So each of these is a tile. Each of these is a tile. Now let me see if for this one, let me see if I'm comfortable sharing this code, because if it's a lot of somebody else's code, then I wouldn't necessarily feel comfortable. I have other comments I used at some point. Some of these comments are pretty identical to some of the tutorials out there, so I don't know. I guess it doesn't matter that much, to be honest. As far as the code is concerned, up until now, I'm definitely comfortable sharing. I think all of this is perfectly fine to share, but I'm not sure about all the comments, though. Who cares? So if you guys want me to share this in the in a paste bin or on the description or something, I can always do that. So you wouldn't have to type all this crap out if you want to follow along. And that generally applies for any of my content. So it's, you know, sometimes I don't always remember to put it in the description so you can easily copy paste. But if you leave a comment, I'll do it. So let's walk through this a bit. This is just palette information. So writing to PPU, but it's stored in 3700. And we saw here, that's this part. So this is palette data, 32 bits. Sorry, 32 bytes, not bits. That's the hexadecimal here. In this loop, compares to X. Branches are not equal. Now we got this craziness. So both of these are using the same pattern table. That's probably weird. While I go to the restroom real quick, I'm gonna think about that. That's probably weird. We probably want to change that. Even though background is getting rendered. This is what we've got here in this file, and we can move around. So kind of getting like the NES Ghostbusters vibes here, if you think of this as a ghost. But anyway, BRB. I have an idea. Let me look at a bigger project. So, in the Nerdy Nights one, let's look. They have two Palm things. Let's take a look at their code. So, because I want to figure out. Hold on. Here, I'm using the same pattern tables for the sprites and the backgrounds. I think that's weird. But so let's, anyway, I'll look at an example that is probably better. Doing things better. Now this is a different, the format here is a bit different because this is a different, it's written for a different assembler. It's written for NESasm. But these are just bytes being sort of reserved. Basically global variables, so you can think of them like that. So loading palettes. So again, 3700. They are writing 32 bytes. Cool. That's probably the same, functionally exactly the same as what I've got. Some initial whatever for the game. So, right, 1 and then 0. So what I have all zeros, right? So it is pattern table 0 for sprites and pattern table 1 for the background. Enable sprites, enable background. Let's see here. So sprites and background are they the middle bits? Yeah, the two middle bits, which are these two. That's for enabling sprites, enabling background. So these other ones, no clipping on left side. So it's got two of these other bits toggled. Show sprites in leftmost 8 pixels of screen. Show background in leftmost 8 pixels of screen. Okay. It's got the infinite loop that waits for this NMI interrupt that happens basically once every frame. All right. Now I believe this is just a rendering. Well, I call it rendering, but okay, this is sending the sprite data to the PPU. But where is that getting sent? And I want to find the information about that in here as well for the PPU registers, this documentation here. So it's using 2003, and by the way, this is identical to how I'm doing to all my programs as well. Pretty much all my programs have sprites in them, and they all do this. But anyway, 2003, 4014 is these ones, right? So let's take a look. Sprite RAM address, yeah. So I'm curious, 2004, where is that at? This is not, okay, it doesn't use 2004 anywhere. Do not write directly to this register in most cases, because changes to OAM should normally be made only during VBlank. So this is the DMA. So direct memory addressing, I think, is the DMA. And so this is where it's going to, wait. Anyway, it starts the transfer of this sprite data. Where does it transfer it to, though? Let's see. So anyway, here we are. This stuff is intense, but once I have a good grasp of this stuff, man, it's gonna be great. And let's see, DMA, director memory addressing, I think. I like how it doesn't say what it stands for. Ugh. I think in here they talk about it. Direct memory access. Okay. Anyway, let's go back. Direct memory access. Always copies 256 bytes. And the source address always... So this is really for copying those sprites. Okay, now I feel like I understand this, and I want to go back to the 2003 PPU register. Takes about 500 cycles. That's interesting, because I think, is there a way? Well, in some games it would be interesting to use the debugger and then just set a breakpoint anywhere that's writing to this memory address. I guess you could say that for pretty much all the PPU addresses, but PPU registers. Because VBlank is so short, and because changing this, the address rather, that's the that's 2003. Okay, so normally this is only done in VBlank. So basically what it sounds like to me is pretty much every game, right as soon as the NMI is triggered, you do this, and it writes all your sprites into the PPU. And basically that's what you're going to do every game you make, pretty much no matter what, maybe with some very rare exceptions. That's what it sounds like. You're just always going to do that. OEM consists of dynamic RAM, DRAM. Decays if not refreshed often enough. That's why you have to do it every friggin' time. Yes. It's different on these two. Refresh happens automatically. Anytime a row is read or written. Interesting. This might be getting into some technical details that don't really matter too much. But this tells us, you know, we need to do this every frame. But I'm still going to read this. Da-dee-dee-da-dee-da. Well, that's interesting. So for PAL, there's a time on the 24th scan line, or about there, where OEM cannot be written. This means that this is limited to the start of VBlank. Anyway, I think I'm always just going to be writing it at the beginning of the NMI, at the beginning of VBlank. NTSC VBlank is shorter than the PAL one. Blah, blah. God, this is exhausting. Really, seriously, this is exhausting. I do not care, but I need to get through this. NMI handlers will finish. What is this even talking about? My brain is turning to mush. So I'm skipping this half sentence because I can't process it. Either case, la la la, not decaying if it is not updated. Now I'm confused. So lag frames are frames where the CPU did not finish its work before V-blank. Interesting. One day maybe I'll have a program sophisticated enough for that. In either case, okay, so on lag frames, you don't need to do it. That's the takeaway. But I'm not in the world of having lag frames yet. Okay, this was very technical. I got enough information in my head, though, for this. Good. It's good to know that the PPU has some internal registers. VTXW. So, yeah. We're going to be using... This information is going to be important when I learn how to do scrolling. Described in detail on PP scrolling. So, we'll wait until then for really... I've read it once. About the internal registers of the PPU. Oh my god, this is exhausting. So, yeah, at some point, I need to have read pretty much all these docs. Scrolling will be later, and 2003, I think I get it well enough. Anyway, there's a lot of technical details. I'm not going to read through every single detail right now. But it's homework. I got to read this stuff at some point. So normally we don't do this. And sure enough, it's not in this program. They're not using the 2004 register because we do the sprites here using this that we just read all about. Okay. So I've made a lot of progress here. I know that 2005 has to do with scrolling. We're not there yet. I know that 2004, probably I never need to use it. I know what 2003 is about. I know what this one's about. These ones I kind of understand, but not quite as well. We've studied the poop out of these two on the stream today and made good comments related to them. I need to learn, although this is probably... I think, wait, hold on. Yeah. We use this when we're waiting for the V-blank here. Coolness. Anyway, the learning of this stuff is not going to finish today. Just keep making progress. But, okay, those are the PPU registers. However, this memory map I'm still not totally 100% comfortable with. This part I'm fine with now. So again, pattern tables are, I guess, 4 kilobytes, huh? Is that right? Is my math right? I think that's right. 4 kilobytes. I'm a little surprised it's that big. But maybe I shouldn't be surprised. 4 kilobytes for pattern tables. Anyway, so here in this program... Let's move this over a bit now. In this program, where is it? They're using pattern table 0 and then pattern table 1 separately for sprites and background. I think that's a better idea. We just researched the bananas out of this. Feel good about it. Now they're doing this again. We had this before. Not totally sure, you know, that this would be necessary, but I believe them. Tell the preview there's no background scrolling. We got control. Oh, we got the what they call the game engine. Okay. Gotta move ball right, move ball left, move ball up, move ball down. Maybe this is not being implemented late. Yeah, it's not. It's obviously not being implemented yet because it only simply returns. Taking in data from the controllers, and that's it. So the 32 bytes of palette information. Let's see where this is getting used exactly. Is it not getting used? That's kind of surprising if that's true. And we've got an 8 kilobyte graphics file with character data. 8 kilobytes because there's 2 pattern tables. Each of them are 4 kilobytes. There you go. Not sure where this is being used, if it's being used, and then not sure where we're accessing the character data exactly here. But let's actually, just in case it's not being used. In case it's not being used, let's go to, there's the most advanced of the basic tutorials. He's here, so this is the Big Daddy boss. Okay. Sprite and then background. Sprites. I feel like it's sprites from table 1 and then background from table 0. I feel like it's the other way. But whatever, let's move on. Now we have this draw score thing. So this is probably going to make use of the character data. I definitely expect that. This is pretty exhausting work, but it's going to pay off. Draw score. So I believe this is the key that I want to look at here, but let's come back to it. Let's look at the rest of the code a little bit. Increment score, controller stuff, and then that other stuff. Okay, so these are not memory addresses, these are actual numbers. So I don't see, let's see what's going on with 1s and 10s here, what this is about. Byte for each digit. Okay, this is just storing information. Cool. Yeah, so I don't think, so it's here. This is what we need to look at. So, let's do it. 2002, 2006. So start drawing the score at PPU 2020. So it's loading in these the memory address 2020 here, but 2000. Okay, so this one is the PPU status. And 2006. So let me see if I have this kind of stuff going on in my code. Yeah, it's the same as here. So this is actually, wait, 2002, 2006. Interesting. So it's start drawing the score at 2020. I don't get it. Yeah, I don't get it. I friggin' don't get it. (2002, 2006). Let's check the docs. Oh god, I might be getting close to my limit on here. But I really just want to finish this last little bit. Jeebus. Let me check the tutorial. Let's just do a search for 2002 here. So that's interesting. So they don't explain anything about it, except this is the first thing that they explain. I wonder if there's anything about latches in here. Latch. God. The right latch. Right, so 2006, okay. So I was talking about these before, right? And I said, I have a good understanding of this. I have a good enough understanding of these. Scroll we do later. 2006 and 2007, I said I kind of get them, but not really. But it sounds like this is just 2006 and 2007 are where you give the you set an address in the PPU and then you write to that address. Because this other stuff that we did was before with these three registers was only to do with sprite data. So now, and this stuff is not going to, this stuff by itself is not going to allow us to write pattern tables. Am I calling it the right thing? Yeah, pattern tables. So if we want to write pattern tables, I think we need to use these. So this is my code, and these are palettes. And here is the tutorial code 2020. So does the tutorial explain about pattern tables? So I'm going to type in pattern, search for that. Let's go to the beginning. All the pattern stuff. So this is not related. Pattern tables. These are where the actual tile data is stored. Each pattern table is 256 tiles. So it's going to be 4 bytes per tile. You have the Y position, the sprite number, the sprite attributes, and the X position. So that is 1 kilobyte per pattern table. 1 kilobyte per pattern table is what we have. Is that? No, these are 4 kilobytes. Grr, what's going on? Brain fail. Wait, hold on. 256 tiles. A tile is 8 by 8. Tile is 8 by 8. All right, let's use the Google calculator here. So, 256 tiles, 8 by 8, which we could just do 64. And that's 4 kilobytes, right? So my brain might be saying incredibly dumb things right now. This is 16 kilobytes. Did I just say it's 4? That's 16 kilobytes. This is 4 kilobytes. But altogether it's 16 kilobytes. I'm confused. Oh boy, am I confused and dumb. It's 2 bits per pixel. What? 256 tiles. They're 8 by 8. And then 2 bits per pixel. Wait. But these... Okay, these are bits now. Then divide by 8 to get bytes. 4 kilobytes. It's making sense. Hooray. So 2 bits per pixel. Two bits per pixel in the attribute table. That confuses the heck out of me. Rendering on the NES is actually quite complicated. It's very complicated. It's very complicated. So attribute table then is 2 bits per 2 by 2 tiles. Where does this attribute table data go? Don't see anything. Is that the name table data? So name table is 0400 in size, which is 1 kilobyte. Yeah, 1 kilobyte is a name table. I don't know about how much that is. Anyway, he says lower. This like could not be more confusing. So lower 2 bits from pattern table, upper 2 bits from attribute table. Why? Why is it so confusing? After finishing the search, I'm going to search for attribute. Anyway. Oh my god. The final changes are to tell. Okay. That's what they mean by final changes compared to the previous program stuff. The previous versions of their... previous weeks of their tutorial. Okay, we're back. We wrapped back around. So I'm going to type in attributes. This I don't understand at all. This is different, though. This is a whole byte. This is not... There's 25 occurrences of attribute, okay. So finally is the attribute table that assigns colors on the palette to areas on the screen. Okay. Interesting. The attribute tables may be the most difficult thing to understand. Well, that's my experience. Let's read what they say here above about name tables as well, even though I feel like I kind of understand it, but I actually don't really know. There's more for me to learn. So now 32 by 30 tiles. Let's see here. Let's do math again. 32 by 30 is what? 960 tiles. And we said each namespace is a kilobyte, so kind of makes sense. It's almost a kilobyte of tiles, right? Okay. So it's going to take these from the pattern tables. Right. So if we don't need to worry about scrolling and stuff, we can just use name table 0 at memory address 2000 on the PPU. That makes sense. Not to be confused with the PPU register 2000. Attribute tables. Alright, now we're at the most difficult thing to understand. And maybe if I understand this, maybe, just maybe, I'll have the critical information I need. Alright, here we go. Most difficult thing to understand. Each name table has an attribute table that sets... you know what? It was 960 bytes, so there's extra space for... There's extra space for attributes table. Each name table has an attribute table, so it's going to be tucked in here somewhere. Cool. Now I think I kind of get all of this memory in the PPU. All right. So we will use the one that starts at PPU 23C0. So 2000 plus 960, because this was 960. Most excellent. So what is 960? So 1048 is it? 1024 minus 960. What's that? That's 64. So is an attribute table 64 bytes? Is that how that's going to play out? Let's see. Well, it can't be more than 64 bytes. Whatever size it is, that is what it will be. So they're going 2000 plus 960, okay. I think it should be... I don't understand this, because I feel like it's 32 by 30 tiles. But anyway, wait, 32 by 32 pixel grid. Okay, hold on. So yeah, okay, so each of these little cells in the grid, each of them contains 4 tiles. Is that right? The math is starting to confuse me a bit. I'm confused. You can see there are 8 grid squares horizontally. So there will be 8 attribute bytes horizontally. 1, 2, 3, 4, 5, 6, 7, 8. Each attribute, okay, is a byte. We have 64 bytes. By 2. So this is what they mean by 2 by 2 tile sections. So the attribute byte. So they're giving us an example of the number 7. Why is attribute byte? Why is it 0013? Is that octal? Are they writing octal? This part I really do not understand. Are they writing? Is it octal? It's octal, isn't it? What? Why? No. So let's see. So this 0 is connected here. Why? Well, it's 0. We got 0, 1, 2, 3. Okay. 0 is here. 1 is up here. Okay. I see. So 0013. So they've avoided mentioning octal in here. Actually, that might be making the discussion even more confusing if they're avoiding it. So in octal, it's 0. You know, the number 7 is 0013. Now this probably goes 0013 in this order, maybe. So suppose, I'm a little confused here. So if there's 8 bytes across and then there's 8 bytes down, that's 8 by 8, 64 bytes. Okay, so we were missing 64 bytes in this math, and we've got them. It's 32 by 32, though the screen resolution is 32 by 30, but I guess whatever. I don't get what they're saying here, 4 by 4 tiles. Grid. It's a grid where each cell is... they weren't lying when they said this is really confusing, difficult to understand. I know there's some videos out there about this. I might watch them later off camera. NES Hacker. But I can kind of see, so hold on. We have 4 possibilities here, right? 4 possibilities here, 4 here, 4 here. 4 times 4, 16 times 16, 250. So I can see that there's 256 possibilities, and that would correspond to a byte. How exactly this is playing out, I haven't quite fully understood, but I mean, this example makes sense, but I'm just not sure what would it look like if you put number 2 here, number 3 here, etc. Not sure exactly how this math is playing out. I think if I watch the NES Hacker video, I'll get it. But I see 256 possibilities that corresponds to 1 byte of information. Maybe I get it well enough for now. I mean, it's determining which palette. And you've got 4 palettes loaded in at any time, I believe. I thought each palette was 4 colors. Is it only 3? Alright, so I just want to check palettes. Wrong key. Now I'm confused again. Now I'm freaking confused again. This is ridiculous. Lower 2 bits from pattern table, upper 2 bits from attribute table? What? Okay, I gotta watch the NES Hacker video on this. I think he explains this. This is bonkers. Oh, it's really hard to understand. Anyway, I'm gonna stop there. I was gonna look. I thought I understood it, and I was going to look at the code and see exactly how things are implemented. But I think I need to watch the NES Hacker video, which I'm not going to do on camera here. I really need to understand exactly how this is working. Then look at the code, further make sure that I understand this. But anyway, it's huge progress today. Hopefully I'll be a PPU master shortly. Thanks everyone for commenting and likes and subscribers and all that. Thank you very much. Hope you have a good rest of the day, and goodbye. Take care. Thank you and goodbye.